Okay, today we are going to discuss about the next assembly drawing. I hope I've cleared all the doubts in the previous sessions. So first we have done Cotter joint. Now we are going to do socket spigot joint. This is a little bit different from the previous assembly drawings. So you got to know how to create sleeve and then after that rod and then after that quarter. Here also you'll be having three parts. One is socket, another one is spigot, and another one is cotter. And we have learned how to join them in the previous session. And after that, we have learned how to save it with this section. Then after that, we learned with we have learned what kind of view we will be requiring, whether it is a front view or whether it is top view or side view, all those things, and even the pictorial views, and how to generate bill of materials and how to update the sectional front view of the part, all these things, and even generation of auto balloon on each and every parts of the quarter joint assembly we have done. Uh, that showed us what material are having what kind of properties and how many quantities of different parts are available in the assembly drawing that we have seen in the last assembly session. The same thing has to be done for the even this socket spigot joint. So in this socket spigot joint we are having three main parts. If you compare this with the quarter joint, there we have created only, you can see that, see here, in this we'll be creating only three parts, but we'll be calling it two times. Like the quarter is called two times, and even the rod end is called as called in the assembly for two times. So the total parts will be five parts or five times they are called, or five elements are there in the assembly drawing. Whereas in this socket spigot joint, all three items has to be created, and once we create this all three items, they are called only once in the assembly drawing. So socket will be initial part. First it will be called, this part will be called in the assembly. Then after this, the spigot will be called and it will be inserted in this socket spigot socket inside cylinder of the socket. Then after that, to fix this socket and spigot joint, we'll be having cotter. Okay, we'll be having the third part, cotter. You can see that we are having socket, and socket is having taper of 1:30. You can see that in the front view. See here, you can see this in the front view, and also you can see it in the top view. And after this, we are having another spigot part that is also having the taper of 1:30. So this 1:30 taper has to be fixed inside this socket. Okay, inside this socket. And even though they have given this as 33.25, see here the socket started over here only, so that we have to calculate, and after that we have to just check what is the dimension from this point to this point, and this spigot has to be fitted in this socket. So based upon that we have to calculate this dimension. Okay, we have to calculate this dimension. Total is 36.25. You can see that because it is 222 from that particular thing, and here it is 33.25. So 25 minus 22 will be giving us 3 mm dimension, and if it is added over here, then it will be 36.25. All these things we will be discussing in next class. I'll be teaching you how to create this socket. Okay, then this is considered as base diagram. Then after that, this will be considered as our next part, which is spigot. So this also will be having the required tapering, which is 35.5 mm, and this will be fitted over here. Then once it is done, this quarter will be joined over here. And today we are going to discuss how to draw this taper and how to create this quarter part in the solid part diagram. We have already done it. We have already done it in the previous quarter joint. Once again, we are going to create this quarter for this socket spigot assembly. Okay, socket spigot quarter joint assembly. Okay, now I'll be going to third part. Here I'll be going to third part, and after this, I'll be creating the same part using the dimension of that quarter joint with the dimension of quarter using the dimension given the question using solid edge version 19. Okay, the same thing now will be going to solid part. It's visible, right? Okay, we'll start with the solid part. Okay, and in this solid part, I'll be using dimension given in the quarter. Okay, wait a minute, I'll share the screen. Okay, we have the dimension over here. So the difference between that the previous quarter and here, what we are having in the previous quarter, what we have generated uh, the quarter which was having the straight part in its left side rather than it's in left side. Here we are creating it in left side, sorry, it in right side. Then left side is having tapered position. In the previous quarter, what we have created, this was having straight joint, sorry, straight line, and this was having tapered line. So the construction features of this quarter will be slightly changed, even though they are the method to create this quarter joint or quarter will be remaining same, but this dimension, reading of the dimension will be different from the previous diagram what we have taken, what we have created. So here also, as it is shown in the front view, we have to select the front view first initially. Okay, then after that we have to create a protrusion because it is a rectangular type of or trapezoidal type of uh, part or an entity. It is not circular in nature. So for that purpose, we will be selecting this protrusion instead of revolved protrusion. So I'll be selecting this protrusion. Then after that, I'm selecting this front view. Once I select this front view, I have to create this line. So this initially I'll be creating one line which is having 88 mm. Okay, 88 mm. I'll be creating it. Then after that, I'll be creating a line which is 32.5 mm. Okay, I'll be creating it with the 32.5 mm. So once it is created, the line is created, these two lines has to be kept over here in a centralized manner. So I'll be selecting it from this midpoint and also from this midpoint of this 32.5 mm. So at the intersection point of these two lines, using alignment of this alignment indication, I'll be selecting this line and I'll be moving it to midpoint of this plane. Okay, midpoint of this top plane. So once I keep this in this line, then I can create this another line which is having some dimension. But for that, I should be knowing what is the dimension of this line, because we won't be knowing this tapered. We will be knowing that this is taper of 1:30. So for every movement, this will be having the horizontal dimension will be incremented by 1 mm. So here 30 mm, 1 mm will be increased. So from here to here, if we divide it in 30 mm segment, so here we'll be having 28 mm. Okay, this will be having 30 mm, and here we'll be having once again 30 mm. So 30 plus 30 plus 28 will be giving us total of 88 mm. So this will be 30 mm. So from this point to this point, as it is having 32.5 mm, this dimension will be equivalent to 33.5 mm because it is increased by 1 mm. You can see that taper is 1:30. So this will be increased by 1 mm. Now from here to here, another 30 mm it is traveling. Here it will be 34.5 mm. Okay, this will be 34.5 mm. It is 33.5 mm. Now it is 34.5 mm. And from here to here, it is increased at about 9.937. Okay, 0.937 mm. It will be increased. It will not be increased by 1 mm. It is not exactly 1 mm. It is slightly less than 1 mm. So what you can do is you can just check for 38 mm it is 1 mm. So for 28 mm what it will be the length. So that is nothing but 28 into 1 divided by 30 will be giving that answer. It is 0.93333333, like this it will be going. So here, from here to here, from this point, it is increased by 1 mm. Here it is increased by 1 mm, and here it is increased by 0.933 mm. You can take this 0.933 mm. So this will be 35.35.43, then 3, like this it will go on. So we have to select the line command, and from here we have to calculate it. 34 point, you have to mention it as 34, sorry, 35 point 35.43333 mm. Okay, so it will be selecting 35.43 mm. The angle will be 0 degree. The angle will be 0 degree, sorry. This will be, I will be making it as 80 degree. Thirty-five point three three, and now we can join from this point to this point. It will be having the required tapered position. Okay, it will be having required tapered position. Now I'll be mentioning it as 88 mm. This will be 32.5 mm, and this will be 35.43 mm. So we have mentioned it as 35.4333, and this is 34.5, 33.5. As we are going down and we'll be going over here, we'll be getting 32.5. But this also will be having the tapering. Okay, sorry, the arc. It will be having the curved surface, not the straight surface. So for that curved surface, we have to create a arc over here. So I'll be selecting arc by 3 points command. I'm selecting end point to end point. Then after that, I'll be giving the required radius of the arc. Preferably go with the 30 mm radius. Okay, 30 mm radius you'll be creating, and here also you'll be creating it with 30 mm radius. Radius will be 30 mm. Then after that, select trim option, because we have to delete all these lines. So I'll be trimming this line, and also I'll be trimming this line. Now as we have created it, we have to create once again these two lines. Okay, so I'll be deleting this line. From here I'm going to join the two end points. Then after that, you can use connect option. See here, you'll be having connect option. You can select this line and this line, but most of the time it may not work. So for that purpose, delete this and once again create it. If it is straight line, then you can directly use connect option to connect two elements. But when it is curved surface, preferably you create it again. See here, once again it is not created perfectly, so I have to select from this point, and here also I have to select this point. Now all the endpoints are closed. All the endpoint of this quarter, they are closed. So that's why I'm clicking on this return option. Okay. Once I click on this return option, I'll be selecting symmetric extent protrusion, and I'll be mentioning this dimension, which is width of that quarter, which is 7.5 mm. I'll be selecting 7.5 mm, and after that I'll be clicking on this finish operation. Now the quarter is created. The quarter is created, but the round has to be created, because if I go to this top view, see here, it is looking like a rectangle. Instead of that, it should be looking like a elliptical shape in nature. So for that, I'm once again selecting isometric position, or I'll be selecting diametric position, and I'll be clicking on this round operation, and I'll be selecting this edge, and I'll be pressing control. Then I'll be selecting each and every edge of this quarter, vertical edges of this quarter, and I'll be specifying radius as 7.5 divided by 2, because this is considered as diameter of this circle. So radius of the circle will be half of that 7.5. So it is 7.5 divided by 2, which is nothing but 3.75. Okay, 3.75 mm. But I'll be selecting it as edge and corner. Then after that, if you click on this preview option, then after that I'll be clicking on this finish. Okay, now if I go to this top view, you can see that it is in elliptical in nature, but the cut over here, it is not created. That we are going to create it now, but before that we have to check whether the round operation is done or not. The round operation is done over here. Then I'll be selecting once again diametric view. I have to create it over here, but only from this edge of this curvature. So for that, I'll be creating another plane, a parallel plane from this horizontal plane. I'll be creating a parallel plane to horizontal plane. So to create it perfectly, I'll be going to front view. Okay, I'll be creating it perfectly. I need this top view, or I'll be zooming this area. You can see this. I need this end point. So from this end point only, I'll be creating my cutout, which is a circular cutout. Now from this plane, I have to create my cutout. So I'll be selecting cutout option, and I'll be selecting this parallel plane. And after this, I'll be creating a circle which is having which will be having radius of 60 mm. So I have to create a cutout which is having a radius equivalent to 60 mm. So 60 mm radius will be created on this particular line. Okay, on this particular line, or I'll be creating it somewhere here. Okay, I'll be creating it somewhere here, so that to move it perfectly on that point, you'll come to know where I'm moving it. But see here, the distance from the two circles, like a circular cutout here and circular cutout over here, distance from those two things, will come to know that it is 2.5. So from the axis center, it is how much? It is half of that 2.5. So if I measure from this point, this will be having half of the 2.5 mm dimension. What is that? So the length should be half of this 2.5 mm, which is 1.25 mm. So I've created one line over here. Then after this, once again I have to create another line which is having radius of that circle. radius of that circle. Now we got that point. Okay, we got that point over here. This circle has to be moved over here, and the center point of this circle, center of the circle, has to be moved on this end point of this 60 mm line. On this 60 mm line. Okay. Now this circle is fully closed, but these lines are not fully closed. Okay, if I zoom this, you can see that at the end point of this 1.25 line only, the circumference of this circle is placed. You can see that over here. So I am going to select this. I'll be deleting this line because they are not closed lines, and also I am going to select this small portion. I am going to delete them. If I measure the dimension between this point with respect to this line, it will be giving me 1.25 mm dimension. And also I'll be selecting this circle, and I'll just be checking what is the diameter of this circle. So I'll be selecting and I'll be making it parallel with the dimension. So we'll be coming to know that this is 120 mm diameter, which means radius is 60 mm, and this is 1.25 mm dimension from the center. Now I'll be clicking on this return option. Now it will ask whether you want to cut it inside or you want to cut it outside. I want to cut it outside, so I'll be selecting the dimension over here like this. I've cut it. Okay, then I'll be clicking on this finish operation. Now if I go over there, you can see that the cut of that particular portion has been done. Now once I get that, I'll be going to once again isometric diametric view, and after this I'll be going to mirror copy feature option. Okay, I'll be selecting this mirror copy feature option. I'll be selecting this cutout. Then after that, I'll be going with the smart mirror copy feature. And after that, I'll be selecting this accept. And after that, I'll be selecting the plane from which the mirroring should be happening. So that will be my front view. So with that, even the front end also will be having this option. Now, mirror of this mirror will be happening. So for that, once again, I'll be selecting mirror copy feature, and I'll be selecting mirror option, and after that I'll be selecting mirror copy feature option, and I'll be clicking on this mirror copy feature accept option. Then after that I'll be selecting the top plane so that I can have cutout over here. Okay, now you can see that both the side of this Cotter simultaneously got its cutout, because I have selected even the cutout and also I have selected this mirror. So for that purpose, both the side got its cutout. But if this cutout is different, and if the cutout over here it is different, then you have to select it separately. Okay, you have to select it separately and you have to create it separately. Now entire thing is created by this dimension only. If I go to this top view, sorry, the front view, then it will be looking like this only. Okay, I have to go to this shader edges. See here, the cutout is also shown over here. The cutout is also shown over here. Then after this, if I go to this in the top view, see here, the same cutout is done even in this section. Okay, even in this section, the same thing has been created. Now I'll be moving on to once again diametric uh, view, and after that I'll be going to this shaded with visible edges. Now I'll be saving this part by giving it name in file properties, and in summary I'll be writing the title as Cotter. Okay, I'll be writing it as Cotter. Then the author will be my initial, then I'll be saving it. Then after this I'll be going to this tools, and after that I'll be assigning the material to this. The material for this Cotter is steel, which is already available. So I'll be going to this steel material. Okay, I'll be selecting this steel material. See Cotter, this steel. So I'll be going to this. I'll be clicking on this. Then this has to be saved in the folder, and you have to create another folder, new folder. Here you are going to write socket. We got spy got Cotter joint. So here we are mentioning part 3, which is Cotter. Okay, we have created Cotter over here. The difference between this Cotter and the earlier one is the dimension. Dimension of that Cotter is different. This Cotter is different. So that's why we have created it again. Otherwise, the same Cotter could have been used even for this the socket spigot joint, but the dimension of this Cotter is slightly different from that Cotter which we have created earlier. So for that purpose we have created this Cotter. Okay, now if anybody is having any doubt regarding anything, you can ask me. You can unmute yourself and you can tell me. If any doubt is there, you can ask me. Otherwise, don't leave the meeting. I'll just check give the attendance in the continue. Okay. So if anybody is having any doubt regarding anything, you can ask me for this Cotter part. Okay. If anybody is having any doubt regarding anything, you can ask him. Okay. Uh, if you don't have any doubt, then you can put your attendance in the chat box, and after that you can leave the meeting. Okay. Put your attendance in the chat box, and after that you can leave the meeting. If you don't have any doubt regarding this part creation. Mohammed Shoaib, if you are having any doubt regarding anything, you can ask me. Otherwise, you can leave the meeting. Put your attendance, and after that, you can leave the meeting. Okay.